Hi everyone, welcome to the part two of the stream for Global Hack Week Cloud. How are you all doing? I hope you are all having super fun and learning a lot in this Global Hack Week series. Um, let's wait for a few more moments before all the folks join in and then we can get started. Hi, Sahiti, welcome to the stream. Welcome everyone. We have Vivek, we have Sahiti, and we have other folks. So welcome everyone. Uh, I'm just waiting for a few more folks to join in, and then we can get started with the stream. So just for your information, this is the part two of our technical series of deploying your application on cloud in different ways. So in part one, yesterday we covered how we can use the Azure virtual machines and use that to deploy our application. It provided us with a lot of customization option and we had a lot of control in that. But today we will shift from using VMs to using more managed services that is provided by Azure. In particular, we will be using the Azure Web Apps and the Azure Static Web Apps to deploy our application. So even if you miss the part one, that's no problem because we are going to take a different approach. So even if you were not there for the part one. So you will be able to follow along and catch up with everything that you need. So yeah, that's the disclaimer that you don't necessarily have to watch the part one if you could not join yesterday. So welcome everyone. Yep. Hi everyone. And I hope my screen is visible. Let me know throughout the stream if you face any issues with the streaming or if you have any questions to ask, then just feel free to leave a comment wherever you're watching from on Twitch or YouTube, and then I will be able to answer that live. So that's it. So let me go to my slides and we can get started now. Welcome everyone. All right, I am Sagar and I am a coach here at Major League Hacking. And professionally, I am in the DevOps and cloud native space for over 2 years now. And I'm also doing my master's at TU Munich in Germany. And then last weekend, I had a super nice activities and fun time in Porto in Portugal. So that was a great time. And yeah, that was much needed as well from my semester break. So once again, welcome everyone to the Global Hack Week Cloud Week. And today we are going to talk about the deploying MERN application in Microsoft Azure. One very important thing that I want to tell you all is um, I have created a guide with all the commands and all the code snippets that we need for the streaming. So it's under this link, mls.link/deploy with Sagar. So if you want to get any of the resources that I showcase in the stream, then it's all here. So just make sure you go ahead and check out this link. I will quickly put this on the StreamYard as well. Give me a moment. We have Hello Pal. Yep, welcome to the stream. You did not miss much. We have just getting started, and then we are just talking about what's going to be the part of the stream today and all the information that you need. So the most important thing is this link right here. So let me put this on the stream. Give me a second. Deploy with Sagar. Yep. So this one is the link, and you can get all the resources for the stream over here. We have uh, the creative game live. So welcome to the stream as well. So let's get started. This is the link that you can follow along. Um, moving ahead, so this is what we covered yesterday. So that was the part one of this stream. So we covered about the different cloud service model and in particular using the virtual machines on Microsoft Azure. We learned how to create the VM from scratch, what are the different configuration for our networking and security uh, configurations, as well as the storage, the other parameters that you need to take care of, such as choosing the RAM and CPU and all those things. So we covered that yesterday, and then we deployed our MERN stack application. So we installed the MongoDB on our VM, and then we installed our Node packages for our backend and front end, and then we used PM2 as the process manager to serve our Node application and also to serve the React static build. So that was about yesterday, and we finally accessed the web application using the public IP of the virtual machine. But today we are going to take it a step further, and this is what a real practice looks like more, because normally as a developer you don't want to focus much on configuring the VMs and all those things. It is very much needed for the complex application, but for simple projects and for small startups or those products that you don't want to manage everything by yourself, then the managed services are a great way to handle that. So cloud service provider such as Azure, Google Cloud, or AWS, they provide different services, and then we can just use that services, and with minimum configuration and with minimum setup, we have our application up and running. Um, Yep, but it does have some downsides that we will talk more in the stream. But yeah, it makes our deployment a lot easier. So in particular, we will talk about the Azure Web Apps, which is mainly used for running our APIs. And in this case, we are going to use Node.js. And then we have the static web app from Azure, and this is used to serve our single page applications. In this case, since we are using the MERN stack, it's going to be React application. And then we will also talk about GitHub Actions, which automates our deployment process. So whenever you have any new changes in your uh, application code, whether it's front end or back end, you just simply need to push it to GitHub. And then the GitHub Action takes care of the rest. It builds the new application for your React, or it updates your APIs, and then it is automatically synced with Azure Web Apps or Azure Static Web Apps live. So any new changes that you pushed to your GitHub repository will also be reflected in a live application. So that's taken care by Azure GitHub Actions. And then we will have a demo of all these things. We will deploy the same one app that we used yesterday, but today we using the managed services instead. And then we will also set up the workflow for the GitHub Actions. And finally, that's a really good bonus for you all. We will also set up a custom domain. So if you want to have a custom domain for your application with your Azure Web Apps or static web apps, we will also see how you can do that. I hope you all are excited for this one, because it's going to be pretty fun. And that's some teaser for tomorrow. That's going to be the part 3. So we're going to take the serverless approach, and we are going to extend our application using the Azure Function app. And instead of MongoDB that we are going to use today, tomorrow we'll use the Cosmos DB, which supports the MongoDB API, but it's the serverless offering from Azure. So we're going to use that, and we are going to also use different infrastructure as code tools and key vaults to make our application more secure and to automate even the steps for setting up the infrastructure. So instead of clicking on Microsoft Azure portal, we are going to write it with code tomorrow. That's for tomorrow, though. So that's for tomorrow. So let's get started. Yep, let me quickly check the stream if we have any comments. All right, no. Once again, reminder for you all, if you have any questions, please feel free to ask me in the chat. All right, so let me get back to the slides. And this is just a brief disclaimer of the different cloud service model that we have. And we covered about this yesterday, but just to give you a brief overview. So we have 3 different service model mainly. So the first one is the infrastructure as a service. We also call it as IaaS. And this is where the VMs comes into play, because we get a lot of control of what operating system do we want for our VMs, what type of CPU, what type of memory do we want, the storage, the networking, and all those things. We can configure it ourselves. The hardware is still provided by the cloud service provider, but we can do a lot of things on top of those physical hardware residing in some data center around the world. So that's the IaaS. And then we have the platform as a service. So this is what we will cover today. So platform as a service, we get managed services such as the Azure Web Apps and static web apps, and we just need to connect our application code or GitHub repo or do minimum configuration, and most of the things are still managed by the cloud service provider. And finally, we have the software as a service. So this provides us the least amount of control, and think of it as an end user application. So example could be a Gmail, where everything is managed by Google for us. We just use their software. So it's just software as a service provided through the internet. But for developers, mostly they are more inclined towards the platform as a service, because they don't want to do a lot of the DevOps thing, but still want to have some control. So that's platform as a service. And IaaS is for the infrastructure or the full-fledged DevOps teams who handles everything for you. So yeah, this is once again the overview of what I just mentioned. So in software as a service, everything from application to networking to OS is taken care by the service provider. In platform as a service, which what we are going to cover today, we still have control over the applications of what type of application we want to run, how we want to run it, and also the data that the application needs. But the other things are still managed by service provider in IaaS, which provides the most flexibility among these three. It provides all the option for us to manage from applications to OS, but the servers and storage and networking, those things are still managed by the service provider. So we don't have to worry about setting up the LAN ports and all those things. But and on site, you have to do everything by yourself. So it's not even like a cloud. It's everything you manage on your own. It's a private cloud kind of thing, and you do everything by yourself. It's like owning your own data center. All right. So that was about the cloud service model. And now let's talk about the application that we will use today. So it's a Monstack application. So we have MongoDB as our database. And then for the front end, which is accessible by the user, we are using the React application. And for the backend stuff, we have Node.js, which runs JavaScript for our server. So it's a runtime. And we are using Express.js as the Node.js web framework. So that's going to be the framework, and Node.js is the runtime, and React will be the front end, and finally MongoDB as the backend. We will not focus much into the actual code of our application because we are just using it for the demo. Our focus is more on how we can deploy the built application. So let's say you have already built your application and now you want to deploy it so that everyone can access your applications. And that's the focus for the stream, not the application code still. But still, I will describe briefly how the application is structured so that you can get an overview. All right. So let us talk about the first service that we are going to use today. So that's going to be the Azure App Service. So it's a fully managed platform as a service, like I mentioned previously, for hosting different kind of application. And then it takes care of the infrastructure for you. So you don't have to worry about setting up the VMs, configuring network firewalls, or all those things. So it's taken care by Azure for you. And it also helps you to scale your application quickly. So let's say today you have minimum demand. So your application can sustain within just a single VM. So but tomorrow you have more demand or your website get a lot of traffic suddenly, then you need more capacity for your application. If you were to use just the VMs, then you would have to scale your VM, either increase the size of your VM to a bigger one. So that was going to be a vertical scaling. And if or you could also have add another VM, and that was going to be example of the horizontal scaling. But in Azure App Service, you don't have to manage the VM. So Azure App Service will automatically scale the infrastructure for you. You can't even see your VM, and you don't need to, or you don't have to as well. That's the beauty of Azure App Service. Everything is taken care by the Azure for you. And it supports a lot of different runtimes. So today we are going to focus on Node.js, but it also supports Java, .NET Core, .NET, PHP, Python, and a lot of others, which is constantly being added every year. So make sure to look at the list of full supported frameworks. All right. And also it comes with CI/CD support. So like I mentioned, we are going to use GitHub Actions, and we will also see how Azure helps us even create the workflow that we need to set up the CI/CD. So it helps us even in doing that. And it supports a lot of different kind of application, from web apps to mobile apps to just to REST API. So all of that is supported, and you can have more information on the official documentation. So next up, we are going to talk about the Azure Static Apps. So if Azure App Service was for our APIs and backends and those kind of thing, we have static apps for our static content. So this is going to be your front end mostly. So in this case, it's going to be the React application. So we have the Azure Static Web Apps managing that for us. And then, for example, if anything changes in your GitHub, let's say your new feature is updated or you fixed a bug, then with the help of the CI/CD tool, so it could be GitHub Actions, or you could even use Azure DevOps, but we are going to use GitHub Actions today. And then those changes are automatically reflected in your static web apps as well. So we have CI/CD for the static web app as well. And talking about Azure and the Azure services, so there are different ways and there are different methods to access and manage the Azure services. So the one that we are going to use today is the Azure portal. So that's the GUI interface provided by Azure. So we are going to go to the portal and do everything from the ClickOps way. But it also comes with more powerful tools such as Azure CLI, and even it supports there are other ISC tools such as Bicep or Terraform, which helps us automate a lot of things. And tomorrow in the third part, we will also use the Azure CLI as well as the Bicep to create our services. But today, for the sake of easiness and for you all to understand and follow along properly, we are going to use Azure Portal because it provides us with more visibility of what's happening and it's easy to follow along. So we are going to use Azure Portal for that one. Next up, we have GitHub Actions. And this is a tool which is built into GitHub. So if you have a GitHub account and a GitHub repo which hosts your code, you already have access to GitHub Actions. You just need to set it up. So it's a tool which helps you to automate your software workflows right from your code repository, right? And we need to define certain jobs and steps. So just think of it as a collection of different tasks. So we need to define how exactly should GitHub build our application and how exactly should GitHub um, take the build artifact from the build step and then deploy that to whatever hosting platform that we need. It could be Azure, it could be AWS, and whatever specific service within those platforms that we want to deploy. So we will define those jobs and steps, and GitHub Action will perform it one by one, or we can even run it parallelly. So we'll see all of these in actions, and these are event driven. So this means that these actions or this workflow will be triggered if something happens. And in this case, we will define two different events. So one is whenever there is any change in the main branch. So that's going to be the event. And if there is any new commits in the main branch, then the GitHub action will run. And it will perform all the steps that we define to deploy our applications. That is what we want, because normally whenever we merge something to the main branch, it is expected that those are the final code that we want also in production. So that's why we trigger our GitHub Actions to uh, follow the main branch commit changes. But we could also add manual triggers that we will see in a moment. So event can be anything, like I said, from a push to a certain branch, to a pull request, to certain commits, and also commit labels and all those things. So GitHub Actions can be set up to trigger from all those things. And you can do everything from building, testing, and deploying from GitHub with the help of GitHub Actions. So just to give you a bit under the hood information. So first, in GitHub Actions, we have the workflow, which is the entire collection of steps and jobs. Just think of workflow as a collection of steps and jobs. And it is triggered by an event. So once an event. So let us think of this as a push to a main branch. So that's an event. And whenever that happens, the job will run. And there are multiple jobs that a workflow can have. So in this case, we have two jobs in the example. And then each job will have different step. So job one had step one and step two, and job two had step one and step two. And there are an action within those steps. So each step can have different actions. So that's the hierarchy of the GitHub Actions workflow. So event and triggers a job which has different steps, which has different actions. And we're going to use this to build and deploy our application. So for example, the job one could be the build job, which has different steps to build our React application. And then in job two, we take the React build or the production ready static assets. And then we take that from the output of job one and we pass that as an input to job two. And job two does the actual job of deploying that to the Microsoft Azure services. And each of these jobs run on independent runner. Runner is nothing but a server which is spin up by GitHub for us. So we don't have to spin up the server for us to run these different actions. It's already done by GitHub for us. If we want, we can have custom runners, but in our case, we will just use the GitHub action runner. So it runs our actions and it also logs what is happening, so we can have more insight into what is happening under the hood when those things are running. So now is the time for the demo and we'll get started. So let me go back and check the comments. Okay, we have questions. Hello, Paul, service provider as those people who do that jobs. Um, okay, I think you are referring to the GitHub Action jobs. So in this case, GitHub Actions is provided by GitHub. So yeah, it is a service provider, but not the cloud service provider in other sense, like I mentioned, Azure, Google Cloud, AWS, and other. So those are the cloud service provider which provide the different cloud services that we will use. But GitHub Actions, you could think of it as a service provider. GitHub in this case will be the service provider and it runs our workflow. So it is a service provider. It is also a cloud service provider, but not the public cloud like Azure, Microsoft, or Google Cloud. Okay. Um, okay, I have some more reference. IaaS, PaaS. Could you please ask what specific job do you mean in this case? Um, So when I mentioned about IaaS, PaaS, and software as a service, so there are certain aspects that needs to be handled by the service provider. So that's going to be taken care by them. But there are still some other things. For example, if we are using a virtual machine, which is infrastructure as a service, then it is our job to update the operating system or the different libraries and packages that we have within that operating system. So that falls under our responsibility and not them. But for example, if you're using a platform as a service like Azure Managed Services, like web apps and static web apps, then all of these things are taken care by the platform or the service provider, in this case, Azure. I hope that that makes that clear. So there are like separation of concern and the responsibilities within the different labels of service models. All right, so let us now go to the demo. I'll quickly share my screen and then we can get started. Stop screen. All right. I hope you can see my screen. So let me go to the Microsoft Azure portal. And by the way, the link that I mentioned before points you to this specific Notion page. And here you can have all the information about the guide, as well as all the prerequisites that you need. So first thing that you need is a Microsoft Azure account. But before that, please remember to check into the event if you already have not done that. It will help you earn some points for the Global Hack Week, and you can get some swags at the end of the Global Hack Week. So go ahead, and if you have already registered, then you will see a check-in button over here, and you can just click on that to check into the event. So this is for the part 2. And coming back to prerequisites, we need a Microsoft Azure account, and you can go ahead and go to this link. And here, just sign up with your student email, and you should be able to get access to Microsoft Azure account. You don't even need a credit card, so that's super great. And you get $100 free Azure credits for you to experiment with Microsoft Azure. And then once you have signed up and once you can see your credits, then you can access the Azure portal with portal.azure.com. So go ahead and open your portal. And if you are not able to follow along within the live stream, so all of this information are always there in the Notion guide, and I will keep it like this. So you can always come back and check the steps from here. So you should be able to see something like this once you go to portal.azure.com. And then if you click on education, here you can see your actual remaining credits. So let us check for mine. So you can see that for me, I have 93 out of 100. So I have used $7 as of now, but I still have 93 remaining. So you can check your credits if you go to the education tab under home. So that was about the credits and the Azure portal. I hope you all are ready with that. And if not, you can always follow the instruction in the guide and sign up with that. The next thing that we need is a MongoDB Atlas account, because we are going to use MongoDB database, but instead of installing MongoDB locally, that we did yesterday for the virtual machine, we downloaded the MongoDB Community Edition within the VMs and used that within our application. We are going to use a managed cloud database. So MongoDB Atlas in this case provides us a free database that we can use on cloud. So MongoDB has their own cloud, but behind the scene, even MongoDB is using the public cloud service provider like Azure or Google Cloud or AWS. So we're going to sign up with MongoDB, and then we are going to use their Atlas to just access the platform. So let me sign in here. Let me do Google sign in, and then let me use this one. So once that is done, we should be able to get access to the MongoDB portal. Yep, so this is what we have. So I'm just getting ready with all the portals. I'll show you the steps to set up things just in a moment. So first we need a Microsoft Azure account. Second, we need an account in MongoDB Atlas. Make sure you go in and sign up for the MongoDB Atlas. This is also totally free. And then we need to have the CLI and dev CLI for tomorrow's session. So that's not for today. You don't need it today. All right, and the next thing that you need is to clone this specific repository. So we have this repository. You can go and click on the link, And you can either fork or better just clone it and just push it to your own repository. You can also fork it if you want, but if you fork it, then you need to change certain things and parameters in your application code. So I suggest you, regardless if you fork or if you clone the code, to make to clone it locally and make some changes that I will show you, and then push it on your own um, account in GitHub. Yep, that's super important. So that's going to be the demo application that we will use. So I will open up the VS Code and show you exactly how the application is set up. I hope you can see my screen. All right, let me zoom out a bit. I hope it's visible. Let me close this. Let me check if we have some comments. Oh, all right. Screen is not shared. Oh, sorry for that one. I forgot to add it to the screen. Yep. Thanks for the comments. Now I guess you can see my screen, right? So I'll quickly cover what I just explained, and then I'll come back to the stream again. All right. So I was just referring that we sign up. We need to sign up to Microsoft Azure portal, and for that we have a Notion page here. And the Notion page, the link that I have shared earlier, mls.link/deploy with Sagar, it points you to this Notion page. I hope you can see my screen now. I think it's visible. Yep. So it points you to the specific Notion page. And here we have all the prerequisites that we need. So first thing is that we need to sign up for the Microsoft Azure account. So just go ahead and click on this link, sign up with your student email, and you get $100 free credits, and you don't need to enter your credit card information. The next thing that you need to do after creating the Microsoft Azure account is to access the portal, and you can access it via portal.azure.com. So once you are there, you should be able to see something like this. And if you click on Education tab, then you will be able to see the credits that you have remaining. So in this case, I should have something like 93. So yeah, I just have used 7 out of 100. So 93 is remaining one. And the next thing that you need to do is to sign up for a MongoDB Atlas account. So go ahead and click on this link, hackp.ac/MongoDB free. And then you should be able to get to the the MongoDB Atlas portal, and there you need to just sign up with your Google account or any other supported login systems, and then you can create a new organization. So first, you should have a default organization. If not, then just create a new organization. And within the organization, we need to create a project. So I have already created a project. Uh, you can go ahead and click on new project and just enter some name that you want for your project. That should be enough. So I have already gone ahead and create one. I can show you the steps. For example, just go ahead and name your project something like test project, right? And then click on next, and you can just add yourself as the owner, and this is going to create the new project. And once the new project is created, for example, the project is now created, I need to create a database cluster. So I will click on create, and then you can create a free database. So you can see that behind the scene, it is still using the public cloud. But if we use MongoDB Atlas, then we get it for free. But if we directly want to use the Azure, Google, and AWS, we might have to pay. So that's good for us that MongoDB provides it for free for us. So we're going to select the free options, which is more than enough for our demo. And you can name your cluster, GSW cluster, whatever you want, and we're going to select Azure. And for the reason, you can select the one which is nearest to you or your users, because that will reduce the latency to your applications. So whenever your backend makes a request to your database, if your backend and the database are close to each other, then the latency will be reduced. So we are going to put it somewhere in North Europe or West Europe for me. If you are from APAC, you can select one of the India regions or the Hong Kong, and for North America, you can follow along likewise. So I'm going to select Netherlands for me and create deployment. So this will create a database cluster, and I'll get the username for the database as well as the password, right? So I will have access to this one. So let me create a database user. I'll just copy the password for now. All right, so that is now created. And I will choose a click on connection method. And for the drivers, I can click on MongoDB driver. And here, let me go back. Yep, that's going to be the MongoDB driver. And here I need to install MongoDB, but this is for local installation. I don't need to do that now. So it's provisioning, and once the cluster is up and running, you can get the connection string that we need for our application. So let us wait for the MongoDB to provision. So this is going to be done in no time. Let me come back to Azure. So two things that we need: Microsoft Azure account, and the second thing is going to be the MongoDB Atlas account. And within that account, we need to spin up a new database cluster. Yep, that's all that we need to do. And now let me come back to the application code. So the application code link is also in the sample app code repository. So the first link is points you to the CloudWeek demo repo. And here we have our application, the MongoDB application. And let me come back to the VS Code so that I can give you a brief overview of how it works. Before that, let me come back to the stream and check if everything is running. Yep, I think everything is running now. I got a thumbs up, so that means everything is up and running. So let me come back to the VS Code now. And here we have the application folder, and this we have the server and the client. The server is the Node.js application itself, and you can see that the servers.js is the entry point for our application. And if you just go to the home route, and it just logs a message which says server is running, but there are other routes like /record. This is a simple CRUD employee record application where you can see the different information about different employees. You can add information about new employees. So that's a simple to-do like kind of an application, but instead of to-do list, we have the employee records. This is a very simple application in that context. And then we have different route for our records within the routes/record.js. So we have routes to get the list of employees. We have route to get the information about specific employees with their ID. And we have the routes to update and delete the information of the employees. So that's the backend of our application. And you can see that it's listening on port, which is set up via environment variable. And that is very important for us. We need two different things for our backend to run. So if you go to config.env, we need two environment variables that our backend expects. So the first one is the port where the server should be running, and we have set it to 50/50 for the default ones. And the second very important environment variable that is needed for our backend is the MongoDB Atlas URI, because our backend needs to connect to the database, and that is why we need to provide it with the MongoDB Atlas URI. And this is how it will connect to MongoDB Atlas and make sure that it can add or delete or read the record from the database. So it's going to be with this format: MongoDB SRV server, and then this is going to be the username of your database, and that's going to be the password. So username and password for your MongoDB cluster, and this link will be provided by MongoDB Atlas for you. So already have one Atlas you set up before this one, so I'm using that one. So for example, I showed you how you can, not that one. Let me go back to other one. So here, the cluster is now provisioned, and you can see that I got a link, right? So that's going to be my username, and that's going to be my password, and this is the cluster user. So I just need to copy this one. I'll click on copy, and then I'll just paste it here for reference. But I'm not going to run this application locally because I want to do it from the portal itself. So let me just delete the previous one. Yep, let me delete this one, and I will copy the one that I just created from the one. So I'll copy the link, and then here I'll paste it here for reference because we are going to set this up on Microsoft Azure in just a second. So this is what we need for our backend. And once we have that, we can just use npm install and npm run to start the application. So that's for the server. For the client, this is a React application, and it's using Vite as a development environment. So we are going to use Vite to check it during local development, and also to build the React application. So it's using Vite. You can see that if I go to package.json, then it's using Vite for our dev as well as to build the application. And whatever you have over here, you can see the React application is under the SRC folder, and you have different the JavaScript files over here, the different routes and the different components over here. And once you build the application, you will see something like the dist folder. And this is the actual only, this is actually the only folder that we need in our production. So when we want to deploy this application, we do not need any of the React application code. What happens behind the scene is that when we run npm build, it runs the white build command, and that actually runs the React build command to build the production build. And in this case, it's under the dist folder. So this is generated, but we do not push this code to GitHub. It is already done as part of the CI/CD process that I will show you in a moment. So this folder will be generated, and this has all the HTML, CSS, and JavaScript that we need. And browser only needs this to run our front-end application. So that is what we need for the front end. And also front end expects one environment variable like the backend. And the front end, since the front end needs to connect to the backend, we need to provide it with the backend API path. So when I run it locally on my own PC, I can just use HTTP localhost 5050. So that's the port where the backend was running. If I go you back to server and config.env, I can, yeah, you can see that the port was set to 5050 and the server was actually listening on port 5050. So that was the backend, and we need to provide it front end with this link. But when we deploy it to Azure, then our backend we will not be able to access backend from localhost because it's going to be hosted on the Azure Web Apps, which is going to use some other URL and the other services, right? So we are going to use that specific backend URL, and we will change this later on. All right. So that was about the front end and the back end application structure. I hope that provided you with some information. All right. We have some question over, does the URI needs to be in double quotes? That is a really good question. So if I go here, and you can see that I have not injected it at code because I have created a file. And in file, you can just leave it like this because it will be rendered properly if you have these things within a file. And you can see that I have used the, for example, for the server, I also have got the URL over here. I have not used quotes. And in package.json, I have used the --env file to provide it the path of the config.env. So in this case, even if you are not use the double quotation, it should render fine. But if you are setting up the environment from the CLI, so if you, instead of env, you pass it --env and some param. So this way, if you do it like this, then you should always pass the URL in a double quotes, because sometimes the URL can have something like the and percentage. So for example, this specific symbol or some other escape symbol that the build or the runner might not understand. So in that case, if you code it as string, then you are always safe. So for you to be super safe, you can code it as string. But if you are using a file, you don't have to. But if you are doing setting up the environment variable from the terminal or the CLI, then you should always quote your double string. I hope that makes it clear. But if you're just setting it from the file, then you don't have to. All right. We have one more question. Is better to containerize the file before deployment? That's another approach. So that is something that I have covered in some of my past streams last year, I guess. You can always use Docker to deploy, but that's going to be a different approach than if you set up with web applications or static web applications. Because if you use Docker, then we are going to have a Docker image instead. And in order to deploy Docker image, we need supported services. So instead of web apps also support Docker images, but not natively. So we need to do some additional configuration. So if you build your application in a Docker image, then it's better to use the container services instead. For example, in Azure, we have the Azure Container Apps. In AWS, we have the AWS Fargate. And if you are really thinking of a huge and large complex application, then that's where the Kubernetes comes into play. And we used the services like the Azure Kubernetes service or the Elastic Kubernetes service in AWS. So those kind of service. So that's a different approach. But in this part of the stream, we are going to use the managed services, and we can just link our GitHub repo for it to run our application, for Azure to build our application. So this is a different approach. Container is a different approach. It has its own benefits such as portability and easiness to share and deploy your application with other people, and to make our deployment even more easier, and mostly to manage your containers but it has its own downsides, such as added complexity when it comes to orchestrating the container. So that's a really good question, and I am glad that you asked that. But today we are not going to use Dockerfile. If you want to understand how we can use Docker, then you can see one of my previous stream, and then you will be able to follow along with that. So in this case, we are just going to connect our GitHub repo directly to our app service. So whenever you have version upgrades and everything, you need to adjust that within our Azure managed service parameter, because when we set up a web application that you will see in a moment, we need to define the um, versions of our node applications. So if something has changed within the code, then the platform as a service might not support that. So you need to adjust your parameters accordingly. In this case, yep, that's really good questions. All right, so let us move ahead from the containers to actually using the service that we will use today. And once again, yeah, if you want to see how we can do these things with containers, you can watch them. It should be up on the MLS channel. Just search for deploying application using containers, and you should be able to find my stream over there. Yep, that's about that one. So we have set up the portal. We have set up the MongoDB Atlas cluster, and we have all the URI that we need. So this is the URI, which I just copied from the Atlas account. So everything is up and ready. So let us actually go ahead and create the Microsoft Azure services. So I'm in the Microsoft Azure portal, and the first thing that we need to create is the backend, because we have our database already up and running, right? So let us go ahead and create a backend service first. So we have our application code up and running in the GitHub account. So next up, let me go to Microsoft Azure, and you can search for the app services. It's already up here because I already searched this previously. If not, then you can just search for app services. And here you can click on create. And we have different options here. So the first one is the web application and the static web app. With these two, we are going to use it today. But for example, you wanted your database not on MongoDB Atlas, but within your own Azure account. Then you can use Mongo Web App plus database. So what this will do is it will also have your database within the same tenant. And that's something that we will cover tomorrow, because tomorrow, instead of having MongoDB Atlas create a database first, we are going to create a Cosmos DB, Microsoft Cosmos DB, which supports the MongoDB API. So we will be able to run everything within Azure tomorrow. But today we are going to use MongoDB Atlas for the database. So that's a separate one. So let's create a web app first. So I'm going to create a web app, and here you get different information. I hope my screen is visible. Please let me know if it's not. I think it is. Yeah. Okay, cool. That's fine. So first you need to select the subscription, and by default for you all, it should be pointing to Azure for Students subscription, and then you can create a new resource group. So let me go ahead and create a new resource group. So that's going to be TSW stream. That's going to be managed services. So you can name it anything that you want. I just named it this. And the resource group is nothing but the collection of all the Azure services that you use for one project. You can create a resource group in different manners. So some wants to create a resource group for all the service that they want to use for one project. For example, for this project, I'm going to use the Azure Web App. I'm also going to use the Azure Static Web App. I might in future use some monitoring solutions, some logging solutions, some other services in Azure, some managed databases. So I group everything in one specific resource group so that it's easy for me to grab a quick look with all the services and see all the status as one. So it's like a folder where you have the group of related services. But some other people or organization can also create resource group per different departments. So let's say they have their HR department services within one group, your IT department services within another group, your production environment in one group, or dev environment services in another group. So you can create a group in different ways, but I just will create a new one, and I will just put all the services that I use for one project in one group. Okay, that's the resource group thing. And next we have to provide a name for our web application. And here you can see a small thing. Whatever the name that you put here, it's also going to be the name for your DNS or the domain name that Azure websites will provide you for free. So for example, I'm going to name it like GSW. What's the name that I should use in the stream. If you could provide me with some cool name, that would be great. All right. I'll check if someone had some recommendations for the web name. Do anyone has any recommendation for the web app? Let me see. I'll wait for a few more seconds, and if not, I'll try to come up with my own. All right. Seems like we don't have any, so let me come up with one name. That's going to be the GSW CloudMon. Okay, I'm going to name it a simple one, GSW CloudMon. And you can see that it appended our application with this random string just to make sure that the name it's a domain name, so it has to be a unique one. So that's why it's appended with this one. And then there was one question whether we want to use a container. So if you had a Docker file, then you could have also selected container for this one and then selected your Docker stack. But for containers, I would highly suggest to use the container specific service instead of creating a web app, because that will provide you with more options. So for us today, we are going to use code because we are just going to link it to our GitHub repo instead. So, and for runtime, we are going to use the Node 22 long-term support version. You can see that it supports a lot of other things like .NET, Java, PHP, Python, and all the other stack. And for operating system, I'm going to choose the Linux operating system. And again, here we need to select the region. So remember, for MongoDB Atlas, we selected the West Europe region. So I'm also going to do the same thing for here. So here we have the West Europe region, and this will make sure that the backend and the database, although they are managed in different accounts. So I'm using my own Azure account to create a app service for our backend, and I'm also using MongoDB Atlas, which also uses Microsoft Azure, but it's not in our account. It is hosted in their MongoDB account in Azure. So but even though they are in a different account or a different tenant, since they are in a same data center, West Europe, I have selected Azure in the MongoDB Atlas as well. So they are going to be within the same data center, so the latency will be reduced. For example, if I have used AWS for my MongoDB Atlas cluster. And then let's say I selected India region in AWS, then the latency would have been increased because the backend is in West Europe in Microsoft Azure data center, and the front end is in Central India, let's say, in AWS data center. So that's going to add some additional delays. So just try to make sure that you have minimum latency by choosing the same region. All right, so the pricing plan, I'm going to leave this at default. And here you can select different pricing plan. With this one, I get 100 ACU. So in Azure, we call it as Azure Compute Unit. So you can think of this as the virtual CPU units. And then we have the 1.75 as my memory. And at the actual number of virtual CPU, it's going to be one. So that's the plan that I'm going to use. You can use the free one, but the free one is really slow, so I just choose the basic B1. And with you can also get the estimated monthly cost over here. So for basic B1, it's going to be around 13.14 USD per month. And yeah, you can select the ones that you want, but for our demo, basic B1 is more than enough. All right, so let's go ahead and create review and create this one. You can configure a lot of other things like database deployment and monitoring and all those things, but we will configure this later on ourselves. So I'm just going to click on review and create for now. And this will just validate all the details that we have inserted. And then I'm going to click on create. So this will create the web application for us. Just the basic web application, but it does not still have our code. So this will not run because we don't have our application code within this service. So we need to configure this service to connect to our GitHub repo and set up the GitHub Actions workflow for it to run. So remember, this is only for the backend now. We have not touched anything for the front end yet. All right, let us wait for this to complete. Deployment is in progress. It might take some time because behind the scene, you can see that we don't see it here, but behind the scene, what it's actually doing is it's spinning up the different VMs that our application need, but it's all managed by the Azure service for us. So we don't have to see that. You can see that it's creating a lot of different resource. It's creating the FTP servers and the SCM services and all those things. So it's taking care of all those things, but we don't have to manage that ourselves. So that is all completed. So let me go to the resource now. And here we can get the web app interface. And this is our application name that we name. And here you can see that we also get one domain, right? So this was the domain that is for our backend. So this is the domain for our backend. And if you remember, in the home route, we normally should have got something, but since our application does not have anything at the moment, so it's just a blank page, and we cannot access anything. So we need to configure our application to have our application code, and then we will be able to see it. So the status is running, the location and the operating system is fine as we expected. So everything is fine. You can even add a custom domain that we will see later on for our front end. So we will point a custom domain for our front end to use our own. So that's what I'm going to do for the domain, but I will not use a custom domain for the backend because we will not expose our backend to the internet. So later on. So that is about the web app, right? And then what we are going to do is you can also see the log stream. So that's really important tool. So you can see right now we just see connected. We don't have any logs because no application is running inside. At least no user application is running inside the this web app. So it just says connected, but we will see some logs when we install our node environment. And these are just the system logs, not the custom application logs. And here we have environment variables. Remember, I mentioned and I told you that we need to set up environment variable for our application, right? So if I go back to the VS Code, so we need these two environment variables, and we need to provide it with the Atlas URI and the backend port. So we'll also have to set up that in Microsoft Azure, and we are going to use the environment variable tab to do that. So we'll add that. And so actually, let us go ahead and already add that. So for example, the first one is the Atlas URI. And let me just copy the entire thing over here. And just to use the Atlas underscore URI, make sure you name it correctly. And I'm just going to paste the value, right? So this is going to be here, and just I will click on apply Atlas URI. So that is done. Remember, we never push the config.env to GitHub because here we have the credentials, right? Because this is my username and that's my password. These are really secret things. And the config.env, if you see the git ignore file, then that is ignored over here. So we do not push this to GitHub so that no one can access that, because even if the repo is private, you normally, even within your organization, you do not store your secrets or credential within GitHub. It has to be managed by either some keyword services like Azure Keyword that we will see tomorrow, or just inject it directly within the application that you want to use. So since our backend will be managed by the web app, so instead of having the key on GitHub, we just inject it over here. So that's much more secure than having to push it on GitHub account. So that was for the Atlas URI. So next up, we also need to add the port details. So not port Q, that's going to be port 5050 for our backend. And let's click on apply. By the way, when you see something like deployment slot settings, so these are normally the variable that you set when you have like different deployment states. For example, you have a stage environment, you have a testing environment, and finally you have the product environment or the production environment. Um, which is only triggered once you passed both the stage and the testing phase, right? So in those kind of thing, you can have something like the env deployment stage or something as an environment, or the name, and the value could be stage, dev, and production or test. So depending on the value of the environment, it will deploy it to specific instances, but that's not needed for now for us in our case. So we have these two environment variable already set up. So, but now let's go ahead and actually hook up our code. So for that, let's go to the deployment center with under the deployment settings. So, and here within the deployment center, let's just waiting for it to refresh. Yep. Within the deployment center, here I get the option to select my sources. Let me check if the stream is running fine. Yep. All right. So we have some questions. I think you are referring to when I created the web app, there was an option to select code or container. Yep, there is an option to publish the container within the web app, but still you will not get the flexibility and the options to manage your containers if you used the Azure container apps, like the super nice auto scaling that comes with Azure container apps and the service communication. So all of those features are not available within the Azure web apps if you used containers. So still the container is going to run within the Azure platform, but you don't get the full customization options if you used a container specific service and the orchestration that comes with it. So there are different services and ways to handle the same problem, but you have different approach. All right, what did we do after creating the web app for backend? Okay, after creating the backend, we added the environment variables. That's all that we did till now. All right, but I don't see it here. I think I need to refresh it. No. Oh, sorry. I think I did not. I That's a question which helped me to debug something, because I added the value, but I did not click on apply. So let's do it once again so that you can also follow along. So we just need to add the environment variables. So first we need to add the Atlas URI, and you get this from the Atlas portal that I showed you earlier. And not that one. What was the value? The full string after equal to, all right, the total string. And then I need to pass it over here as the value. Yep. So this is going to be the value. I need to click on apply, and I also need to add the port, right? So 5050 and click on apply. And then I need to click on apply again. So that is the step that I missed previously. So yep, I will click on save changes, and now you have the variables. So that is all that we did till now. So we have the environment variables, and now let us go to deployment center to actually connect our application code. So let's go back to the deployment center, and here I will select the GitHub as my source. And since I have already connected my GitHub account to Azure, so I see it as already signed in. But if you're doing this for the first time, then you will see a button. And if you click on that button, then it will ask you to log into your GitHub account. So make sure that you just provide it with your GitHub credentials so that GitHub can, uh, so that Azure can access your GitHub account, because we need to provide Azure with access to our GitHub account and under specific repository, because it needs to read and write something to that repository. Specifically, it needs to read the application code from that repository, and it needs to write the workflow file that we will create. So that's why you need to connect your Azure with your GitHub account, and you can just do that by clicking a button and just signing in with your GitHub ID and credentials. So for me, it's going to be my personal account. So I'm gonna select my account as the organization, and for the repository name you can see here is GSW Cloud Week Demo, right? So I'm going to select the same one. So that's going to be GSW Cloud Week Demo. So this is the repo, and all of my code is in the main branch. So I'm going to select main branch for the trigger. So if you select it, if you have a lot of other branches and you want certain other branch for your deployment and not use the main branch, then you can do that as well. But most of the organization just keep it as main. So that's going to be one. And for the workflow options, I have two different options. The first option is to let Azure create a workflow file for us. So it will create a GitHub Action workflow file for us in our repo, and it will commit that changes to our repo automatically. And we can adjust the workflow file after that according to our needs. So that's one approach. Or if you can write your own workflow file by yourself, if you want to write everything by yourself, then you can use a custom a workflow, and you can select use available workflow and point it to the workflow file. So in my case, you can see that if I go to the repository, the workflow file is always going to be inside the .github folder. So I'll close this for now. The workflow file in GitHub is always going to be in the .github/workflows folder, right? And for my own reference, I have added the reference folder, and I have like the two workflow files. So this is how the final workflow file looks like. Don't be scared of this. I'm going to explain what all of this exactly is. But this is just for my own reference and just to show you the end result. But when I select, I do have a workflow file here, but I will not use this one. And because this is just for reference, and whatever workflow file you have, it needs to be directly within the workflows folder and not inside another subfolder. So I'm not going to use this one. These are just for reference. I'm going to ask Azure to create a new workflow file for us so that you all can see what exactly happens and how we need to adjust the workflow file. So I'm going to select add a workflow file for me. in the repository and branch. And you can see that the runtime stack, it has automatically selected Node, because when we created a web app, we selected the runtime as Node 22. And for authentication, so this is for authentication between the Azure and the GitHub Actions. So there needs to be authentication between these two things, because our repository needs to connect to Azure, and our Azure App Service needs to connect to our GitHub repository. So there are two types of authentication. One is basic, which is not recommended, but user identity is the one that we need right now, because what this will do, it will create an identity policy in Azure behind the scene. That is some a bit more advanced security topic, but it will create an identity policy in Azure, and it will grant access to your GitHub account, and it will create a secret that the secret will be used within our repo. So I'll talk to you about those things. And once the identity is created, it needs to be passed on to our GitHub account settings as a secret, and then that is how they will be able to authenticate with each other. But right now, we just select user as an entity, and I will explain how that works in a bit more in a bit later moment. So the subscription is same, and for the identity, I'm going to create a new one. For example, if you already had created a new identity which already had access to your specific repo, and you create multiple web app, you can use the same identity, but I will just create a new one for me. And you can see the workflow configuration. So this is the preview that you get. So it will commit this file under GitHub workflows / man gsw mon.yaml. So this is the workflow file that the Azure will create, and you can see that this will be committed to our repo. So I will close this for now, and I need to click on save. So you can see that I click on saved, and it's setting up the deployment. So what this will do, if I click on refresh, you can see that if I click on refresh, it's taking some time, but you should be able to see a new file over here under workflows. Yeah, you can see that this is now created, and it has the commit. This was added by Azure for us. This is not something that I did by myself. And you can see the workflow file is already here, right? So workflow file is here, and now let us actually look at the workflow. And whenever there is a workflow file, I will just zoom it a bit so that you all can see. So this is the workflow file, right? And this is just the name of the workflow that was added by Azure. And like I mentioned, there is always be an event that will trigger the workflow. And in this case, it's going to be on push to the branch, which is specified under this list. So the branches can be is of list. So this is following the YAML format. .yml is the YAML extension, and dash means it is an item in a list. So in this case, we just have one item, which is the main branch. So this workflow, so whatever jobs we have defined below in this workflow file, so this will only run whenever there is something that is pushed to the main branch. So that's one action. But there we also have another event. So this is first event, push is the first event, and then we have the workflow dispatch as the second event. So this means that there will be a button in the actions tab that I have over here. So there are two ways to trigger this event. Either I need to push something to the main branch, or I need to go to the action tabs and click on a button to trigger. So this is for manual trigger. Workflow dispatch is for manual triggers by clicking a button, and this is for automated trigger. So that is for whenever something is posted to the main branch. So these are the events. So if I go to actions here, you can see that I have one actions 1 minute ago, right? So this is the latest action these are all the test action that I did previously, but this is the one that we had today. And you can see that under the actions, I have the workflow that was created. So this is the workflow. And since I had the workflow dispatch event triggered, right, that I just showcased you previously, I get this button and I can just click on this button to run the workflow. So that is how I can run the workflow. One way is to come here and click on this button by clicking on the absence, or it gets automatically triggered whenever there is something changed and pushed to the main branch, because we have two different event triggers, right? So that is about that. And you can see that if I come here and this action failed because it in the build step, it is failing, and let's take a look at the log and try to see why it failed. This is expected, and I will show you exactly why. If you click on build, you can see that the actions first installs the Node.js, because remember, to run our application, we need to install the packages, the Node.js packages, and then start the server, right? So it failed here, and if you see the error, then it says something like it could not find the package.json, no source file or directory. It cannot read the package.json. And let us now try to understand why this happens. So let me pull the latest changes, because you can see that this file was these two files, not two files. I think for now we just have the workflow file for the backend. This file was added by Azure, right? So let me come back to VS Code and let me pull that over here, because I don't have it on locally right now. Yeah, you can see that I don't have anything under workflows, right? So let me pull that using git pull. I should have the file over here. Yeah, you can see that the file is now here. And let us try to understand why our actions failed. So first, this is the name of the action that I talked, and this is the event that I mentioned. I hope that's clear. Let me check comments if we have any questions. Hi, hi there. Welcome to the stream. I hope you all are following along and having some fun in the Global Hack Week. Welcome back, and let us continue with the session. Again, if you have any questions throughout the session, please feel free to let me know in the chat or the comments. All right, let us go back to the workflow file. And here you can see that we have jobs, right? Because I mentioned in the workflow, we have event, and then we have jobs, which contains multiple steps, right? So first we have the first job. So this is going to be one job. So remember, the indentation matters here. So whatever is on the same indentation label, it's one job. So this is going to be a build job. And then we have the deploy job. So we have two jobs in total in this case. And both of these job runs on independent runner. So we need to define like what type of operating system should the runner run. So runner in this context is just a small server which run these different steps. So each of this job, the build job, will run in one specific server which is created by GitHub for us automatically. It's free of cost for us to use. And then this is another job. So this is going to run on a different server, not on the same server as the first one. And then it's gonna that's why we need to define the run parameter, and we need to define the operating system that the runner will use. And we have provided the permission to read our application code. And here you can see that this is required for the checkout action. So we need to provide it with the permissions. Sorry for the, yeah, this is the comment. And then for the steps, since this job has different step, we have the first step which uses the actions checkout. And what this does is that it's a predefined action. So I can click on this one to open the repo for the extension. So this is the GitHub actions that we already get provided built in, and we can just use it from the marketplace. So what this does is that it checks it helps GitHub actions to read the code from our repository. So that is just that it does. For example, we use the git checkout command. It's very similar to that. It Because our GitHub actions need to read the code from our repository, we use this action. That is all that it does. Then remember the step that we need to run our application. We need to install Node.js for our application to run, right? So it does the same thing. It installs the Node.js and it installs the 22 version. And whatever is the latest one, it will install that within the 22 version. So we have our code, we have installed the Node.js, and then it tries to install and build the application. But since this is a backend, and if you go to my app and server and then package.json, I don't have anything for the build script, right? I don't have a build script because this is a backend, so we don't need to build it. We just need to install the package, and then we can just simply run the application. For front end, though, we need to build it, because front end is a React app, so that's why we have a build script. So that is why what I can do is, since my backend does not have a build, so I can just erase that. And I mean, this would also work because it's only works if it is present. It skips if it is not present, but I just like to have my workflow very clear, so I'll delete that. And I also don't have any test script in my application, so I'll just also delete that. So I'll make that changes over here. The next thing is it zips. So once the npm install command is run, normally you get a node modules folder within your application like this, right? And we also do not commit the node modules folder to the repo. So once the npm install is done, it will the node modules folder will be created inside the runner. So remember, this is a runner, right? So this is in the GitHub Actions server. So it will be created, and then it will zip the content of the path into a zip file. And this is where we need to make the changes, because right now it is trying to find the the package for the npm install to run, it needs to find the package.json within the root of the repository. But remember, we do not have the package.json within the root of the repository, because our application has an app folder with has a server folder, and only inside this folder we have the package.json. So when I run this command, it will not work, and that is why the error was there, because it did not find package.json in the root of the repository. So that is why we need to change the path. And if you go and look at my guide, let me come back to the guide. If you go ahead and look at my, just give me a moment. I could not find the guide. Yep. If you go ahead and look at my guide, and you can see the follow along guide for part 2, go ahead and here. And this is the structure of our application, right? So the React application, which is served with static web app, the backend application, which is served with web app, Azure web app, and the client only access the front end, which is the static web app, and the static web app, which is the front end or a React application, makes the API request to the backend, and it makes the database queries to the MongoDB at last, right? And it serves MongoDB is served within using the MongoDB at last. And the developer, whenever they push some changes, the GitHub action will run, and it will build the artifact to deploy it to either the front end or the back end. So that's the structure. So we did all of that. We will come to this point later on, but here you can see that we need to make the changes, right? And that's why we need to set up a working directory over here like this. So I'll just copy that one, and this will make sure that uh, the npm install runs from the app/server directory, and now it will be able to find the package.json, so that error should be gone. But we also need to make some more changes. So let me quickly come back to the guide, and you can see that even when creating a zip file, we need to run it from the app/server directory. So I will just copy, delete this to file, and just make sure it is in the same label. So here, since the working directory is set to app/server, it will create a release.zip with everything that is inside the server folder. So this is a part to the context of what it will be zip. So, and dash r is just a recursive command, so it will zip everything inside any subfolders as well. So you can see that node modules have different subfolders, so it will zip everything within different labels of subfolders. So whatever is inside the app/server, it will zip everything. But first we need to install the packages, and then zip everything within that packages. So let us see what else do we need to configure. And then after that, we need to upload the artifact for the next job, and that for that we need to provide the path as well. And finally, we provided the path, but the path is not release.zip, because if you just put it as release.zip, then it will expect the release.zip to be in the root folder. But remember that when we zipped the file, we zipped it also inside the app/server path, right? So the zip file will also be here. uh, so in this case, we need to update the path to be app/server/read.zip, because it will zip all the contents of here into a release.zip file, and that zip file is also within the server folder and not in root. So we need to update the path here. So we made some changes over here. So first we set up the working directory for our npm install step. I can just rename this to npm install, and then we also set up a working directory for our zip step, and finally we use the path for our uploading. So what this will do, so this step, so we have 1, 2, 3, 4, 5 step over here, right? So these are 5 steps. And first we checked out our code. So just GitHub Actions can access our code. Second, we install the Node.js within the GitHub Actions runner. Then we install the packages. Then we zipped whatever is inside the server folder. And then we upload the zip file to a temporary repository. So that is all that we did. Let me check the stream. All right. Uh, let me see if my stream is running. I'm just having some issues. My screen, give me a moment and I'll come back. All right, yeah, this is running. My screen was not visible. Give me a moment. All right. I hope you can see my screen now. Can you see my screen now? I think you can. Yep. Uh, I think it should be visible now. Yep. Thanks for the confirmation. And let us go to the and can you also give me a confirmation if you were able to see the screen and everything worked until until the part where I was explaining the jobs for the upload artifact? I will just wait for the confirmation. If you could confirm where if you were able to follow along till the part where I explained about the different jobs. Yeah, all right. We did path for release.zip. That's perfect. All right, let us go back and then let us see what happens here. All right. So that happened, and then we upload the artifact. So we have the release.zip, and this will upload it to a temporary directory which is available to the GitHub Actions runner. So just till now we have a zip file with our node backend code. That is all that we did, and now we have the next job. So this is the deploy job, and what this does, it again runs on a different runner or a server, which is managed by GitHub Actions. So we don't need to worry about that, but we'll use the same operating system. And you can see that it needs build because we are going to use this release.zip, right? Because we need the zip file to deploy it to Microsoft Azure and that's why we need to specify the dependency over here because this action cannot run without completing the build step. So that's why we provided it with needs build. And then we set up the environment. So for example, this for me is I just have a single environment that's production. But if you have like multiple environment, then you can specify a list of your, you can have like deploy it on different environments. So for me, it's going to be a production one. And you can see that the URL is going to be it's going to be taken out from the deploy to web apps. So from here, you can see steps deploy to web app dot outputs URL. So it's gonna take, give me a moment here. It's gonna take the output from here. So you can see the ID of the step. So this is gonna be the ID over here. So what it does is that once it the URL needs to be specified. So once the deploy to web app, this step is done. So you're going to get a URL, and that's going to be within the output of this step. So we are going to access the URL from there. So that is how we set up the URL, because right now we do not know the URL for our web app. So that is why what it does is when it connects to Azure, it will then be able to get the URL. But in this step, we do not have directly the access to the environment, right? Because we only log into Azure and connect with Azure on this specific step. So once this step is done, and then once it tries to deploy to a web app, it can get access to the web app URL. So once this output is done, and it then sets like the environment from there. And then we need to provide the permissions as well. So first is the ID token, which is required for requesting the token. So this is for authentication that we need this one. And then we also need to provide it with the read permission, just like we did it before. We need to provide the read permission for the GitHub Actions to check out our uh, content of the repo. And then we have 1, 2, 3, and 4 steps. The first step is going to be the downloading the artifact from the build step. So here we upload the artifact, and in this job we download the artifact, because remember these two are in a different runner. So this is in a separate server, this is in a separate server. So whatever we have zipped here will not be available directly on this machine. Otherwise we would not have to upload or download, because if it was only within the same server, then we could have just zipped it and then reference it directly when we want to unzip it. So that's why we upload it in the first step, and it's gonna put it in some shared temporary location within the different jobs. So this is gonna be in some shared storage service by GitHub Actions for us, and that is how we can download it over here. So it's going to download the artifact from the shared storage service from GitHub, and that's what we are going to use. You can see that we provide it with the name of the application that we want to, or the name of the zip, name of the artifact that we want to download. So the name of the zip file is still release.zip, but the name of the artifact is node-app. So we have to specify the name here, and then we unzip the artifact because the artifact is release.zip. So that is what we do. And here, finally, we log into Azure, right? And this for this, we need three different things: the client ID, the tenant ID, and the subscription ID. And here you can see that these are all set up as secrets because these are very critical information. So we do not store it within the same workflow file. We need to store it as secrets. And now you might be wondering, okay, but where are these secrets defined? And that is defined within the GitHub repository settings. So let me come back to stream if we have some questions. All right. Is my screen still not visible? Hello. I think my screen is visible on my end. Let me quickly stop and share the screen. Oh, it's sharing a window. Sorry for that. Share a screen. I will share the entire screen now. All right. Now it should be visible. All right. Sorry for that one, folks. Let us see. I think it should be visible now. All right. All right. Now it should be visible. So I'll just quickly recap what I explained before from the part where we upload the artifact for the release.zip. So what happens is that for our build job, so the final step that we did was to create a release.zip file. And then we upload that to a temporary location in GitHub Actions server. And then in the next deploy job, we define the dependency with needs because the build job needs to complete for the deploy job to run. So that is why we need to mention it as needs. And then we need to set up the environment. And here we have the URL, and the URL is going to be provided by the step over here. So step.deploy to web app, we have this step over here, and it's going to get the URL from the output of this step. So that is how we define the environment. We define the permissions. So the ID token is for the JWT token. So this is for authentication with Microsoft Azure. And the contents read is for reading the contents of the source code in our GitHub repo. And then we have four different steps. So the first one is downloading the artifact. So the same release.zip that we have uploaded previously with the name of Node app. So this is the name of the artifact. We need to provide the name over here, and it will download the artifact in this one. Because remember, the build and the deploy job are in a different server. So we need to upload it to one, and then it's going to be hosted on some shared network storage. And then the download artifact will download that in this step. And then we need unzip the release.zip file. And then we log into Azure. And then we have three different secrets that we need to connect to Azure. Because remember, GitHub needs permission to upload the artifact to Microsoft Azure. So we need to provide it with the different credentials. So client ID, tenant ID, and subscription ID mainly. And then these are kept as secrets, and we do not expose that directly in the workflow file. So now let's go ahead and see how these secrets are stored. And then we'll come back to the deploy stage, which is the final part. All right. All right. So let us come back, and then let us go to the repo. I hope my screen is now visible and working fine. Let us come back to the repo, and here you can see that if I go to settings now, you can see that under the security thing, and then we have the secrets and variable under actions tab, you can see that all these secrets are added by Azure. So I have some other ones as well, the old ones, but you can see the latest one was 21 minutes ago, and I have like the client ID, the subscription ID, and this one should be the tenant ID. So these three credentials are added by Microsoft Azure automatically, because remember when we set up the deployment, we provided it with access to our GitHub account. So when it created the workflow file, it also created these secrets, and then it referenced this secret within the workflow file. So that is how it is able to authenticate with Azure. And finally, the deploy action is there. It uses this web deploy action from GitHub. You can see that it's provided by Microsoft Azure itself, and then it uses this specific actions. You can find more information of how it exactly does that, but we just need to use it. We don't have to understand that in depth. We use that, and then we have to provide it with three different things. So we have to provide it with the app name, So that's going to be the application name that we use. The slot name is the production because I just have one environment over here that I defined. But if you had, let's say, multiple environments, then you can change the slot over here. And then we need to provide it with package. So that's going to be the root because we have already unzipped and unzipped this in the root of this runner, right? Because we have not in this specific job, the unzip thing is done in the root, so we have to provide it the path to the package. So that's going to be dot. Let us check the guide if we have something else, part 2, and then that should be done. Yep, that is all that we need to do. And then let us go ahead and click on that one, and let's click on Control S, and let's just try to push this and see if our backend is working properly or not. All right, let me commit and push these changes. I have already staged the changes, and then that's gonna be add workflow file for backend. So that is what I will do, and I will just post the changes. Yep, so this should be there. And now let us see if our action is up and running in the repo. Give me a second. Yep, let me come back here. And if I go to actions now, the workflows will have been triggered. You can see that the workflow is now triggered and it's running. And you can see that the build job is already succeeded. It was able to find the package.json because we changed the working directory. It was able to zip the artifact. It was able to upload the artifact. You can see the logs of all the steps over here. Uh, you can see the logs of all the steps over here of what it exactly does. And if something fails, then you can always come here and check the logs for the each step. So that is how we are going to do it. And then in the deploy stage, you can see that it is able to also log into Azure. It is succeeded because we have the secrets over there. And then you can also see that it's now trying to deploy the Azure Web Apps. All right, so hopefully this will be succeeded, and we will see if the backend is up and running when we access the URL for the backend. Let me come back to the stream and see if we have something else. Yep, that's great for the recommendation. I actually had a second screen, but it has broken down just before the weekend, so I'm not able to use that one. But yeah, for the next streams, this would be possible because I have already sent it for repair, so that would be fine. I have a second screen, but unfortunately, I could not use it today. Yep. Um, I don't get the questions. So we have a question of even after saying path, still shows error, but I did not. Um, I'm not. Could you please explain what kind of error do you get? You can post it in the chat, and I can have a look after that. So that is done. So let us see exactly if the deploy job runs properly. Yep, you can see that the deploy job has also succeeded, and now it should be done because we are in the last step. So both the build and step jobs are succeeded. You can see we have a green tick. So let me come back to the web app, and here let us see if this is working fine. All right, GSW Cloud Mon. And if I go to the domain, open the domain, all right, we should be able to get the application. Let us see the logs, what the log says. Okay, something is wrong here. Enter something export notepad. So these are the setup. Let's see if I think it's starting right now. So we need to wait for a few moments. Node server start. Let us wait for this to complete and see if everything runs fine, because as far as I remember, we have set up the environment variable, so that should be fine. So let me come back to the log stream again. And welcome. We have everything running, npm run. Yep. We have some errors, node server, but yeah, server is listening on port 5050. That is fine. Connection is failure error, so it is not able to connect, I guess, to the MongoDB. Let us see why. I think that's because of the network settings. So we need to also enable that. So right now, you can see that it is failing to connect to the MongoDB, right? Because Mongo network error, and we can see that the the termination has occurred and it is not able to connect to our MongoDB server. That is because, remember, MongoDB, even though it's running, it's managed by Atlast within the Microsoft Azure, but it's in a separate account. So by default, our backend cannot access someone else's account, right? Or services within someone else's account. So that is why we need to enable the network access. So if I go here, and then if I go to the database cluster, and within the cluster, then if I go here, and under configuration, I should be, no, I don't want to change that. I can set up the network access from here, then IP list access, then I'm going to add an IP, and I'm going to just allow from anywhere for now. By normally, you should only allow it from the IP of your backend, but right now, since we are using a managed service and we don't have a dedicated IP because it changes dynamically, we are restricting it from we are allowing it from anywhere, but normally you should have a list of range of IPs that your backend in Azure can use, or in production, we can use a concept of service principal to do that, but that's out of scope for this demo. So we are just going to allow it from anywhere, and then I can confirm that. So now, once this is done, my application should be able to access that again. All right, so let us just wait for this to be active. And in the meantime, let us also set up the front end of our application. So I'll wait for this to complete in here because it's going to take some time to enable the network access. But now let us go to the static web apps. So let me search for the static web apps and let me create a static web app for our front end. So it's going to be a pretty similar process. So I'm going to use the same resource group that I used, the managed services. So this is going to be DSW Cloud Mon. So that's going to be the name of my web app. I'm going to use the standard. You can also use a free if it's a small project. The source, please select GitHub for that one, and it's already logged into my account. And for organization, I'm going to select my private account. The repository is going to be Cloudwick demo, and the branch is going to be main. And then you need to provide the build presets. It has already detected it as React. It's smart enough to detect what type of application I'm using, but you can use a lot of other ones as well. And the app location is within the /app/client, right? Because my front end, if you come back and see the repo, the front end is within app/client. So I need to provide it to that path. It needs to find the package.json path. So that's why I need to provide it with that path, app/client. And the API location, I'm not using Azure Functions. So if you use that, you can use over here. And the output location. So remember, for our build process, we are using Vite, and whenever Vite builds the React app, it creates a dist folder within the client. So you can see I have a dist folder which is created by Vite. So I need to provide it as dist and not build. But for some other build manager, it might have been built. So I'm going to use dist instead of the build for the output location, and then I can uh, preview the workflow file if I want. Yeah, this is going to be the workflow file, and then I can review and create this one. So let us wait for this to validate, and then I'll create a new one. So that should add a second workflow file. So let me come back to Cloud Demo, GitHub workflow, and if I click on refresh, yeah, now I have a second workflow file, and this is talking about how we deploy the front end. But let's see if the actions pass or fails, and then we can come back and see how this works. All right, so this is the workflow that we triggered. This is also automatically triggered because we have set the workflow to trigger whenever we have changes on the main branch. But even though this was just a change on our front end part, both the workflow are triggered. We can rectify this later on. I have showed you in the reference how to do that, so that if you have some changes only in the front end part, only the front end workflow gets triggered. And if you have some changes in the back end part, only the back end workflow gets triggered. So that can also be configured. But now both the actions are running. Let us see if we have some errors or not. Looks like it's installing the packages, so we don't have any error update until now. These are just some warning for the packages. So looks like the build process is done. Let us see how this goes. And then Let us go back to MongoDB. Yeah, you can see that the IP is now whitelisted. Every IP can connect to our MongoDB, but they need to have the credentials, of course. And then if I can go back to my database, let me go back to my database, and then I will just restart the application. Yeah, I'll just restart the web app. And if this does not fix, then I'll just also retrigger the deployment, make sure the application is running. All right, let us check the logs. And let us see if everything is running. These are the operating system logs. Let us wait for this to complete. In the meantime, let's see what happened in the workflow file. So you can see that build and deploy job is running. And if I go back to my front end, let us go back to static web app. I'll go to the resource. So this is the portal for the front end. Let me see. Okay, everything is fine. I don't see any new questions. And then I have the GSW Cloud static apps. And then here's the URL for the backend, sorry, the front end. And then you can see the deployment history from here, the GitHub Actions runs and everything. So these can directly point you to that one. And here we also have an environment variable over here. And remember, we need to provide it with the Vite API URL. But these are the runtime environment variable, but we need a build environment variable because, for example, we had .env, right? So we need to provide it the Vite API URL. But this is not a runtime environment. This is actually, we need it before the build process happens. So that is why we need to provide it beforehand. And that's why if I can show you, if I go to overview and I click on the URL, you can see that the application loads, right? So this is actually the employee application, but it does not show any records, but I already have some temporary, I should have, right now I don't have any, but let's say if I try to create a new one, Cloud Native Developer, Junior, and I click on save, I don't still see any records, right? Because it's not being able to connect to the backend. I can prove you that if I go to inspect and then click on the console, you can see that it is not able to load the resource, right? Because the server did not respond. It's 404 not found, and it could not connect to the backend. That is because right now we do not have the backend URI in our front end. So we need to set that up, and we need to change that within the workflow file. So if I go ahead and pull the new changes, git pull. So if I go ahead and pull the changes, you can see that I have the front end workflow file over here. And here we need to do something else. So for example, if I show you the reference for the front end, we need to add this specific step before the build process. We need to set the environment variable. So I'm just going to copy this one, and before the build step. So this step after the checkout, and then I will just make sure this is within the correct indentation. All right, this is within the correct indentation. So before it is running the build step, we set the Vite API URI as the GitHub environment. And what this happens is that this will make sure that whenever the build step run, because the client expects the env, right, the Vite API URI as a environment variable, since we set up as a GitHub environment, it will be able to access the Vite API URI. But again, you can see that we are referencing it from the secrets. So we need to have this secret in our repo. So let us go ahead and actually create this secret with the backend URI. So I'm going to go back to the repo settings, right? Going back to the repo and to settings, and I'm going to click on secrets and variables, and I'm going to go ahead and click on actions, new repository secrets, and that was going to be the Vite API URI. And this is the URL of the backend. So we need to provide it with the backend URI. And in this case, yeah, you can see that the backend is also like now currently running. It has successfully connected to MongoDB. So we should be able to see our backend, but I will come back to later on. I need the URL here. You can see that the URL is in the default domain project. And now since the backend is already connected to the connected to MongoDB, I should be able to see server is running message, right? So this means that our backend is able to connect to the front end. So I'll just copy the URL and I will store this as the Byte API URL as a secret because we need this, and you need to always remove the trailing slash at the end. Otherwise, there will be double slash when the front end tries to connect with the backend, and it will fail. So we just need to pass it without the trailing slash, and I'll add it as a secret. Okay, that secret is already exist because I had an old secret with the value. So I'll delete the previous one, Byte API URL. I delete the secret. I'm going to use my password. Yep. And then I will add a new one, Byte API URL, and that's going to be the without the trailing slash. This is going to be the secret. I will add it as a secret. And now what happens is that whenever the workflow runs, it will take that value and it will inject it as a GitHub environment. This is a special um, command that we can use, $GitHub environment. So this parameter will be exposed for all these steps. So whenever this step run, it can access the environment that we set up in the GitHub environment. So that is how we set up the environment. And let us see the guide if we have some other instructions that we need to take care of. So for the front end, yeah, that's all that we need to do. And the output location, we already defined this before. We set it to test instead of build. So that should be enough to access our application. So let us go ahead and just save the changes. I'm going to stage the changes from the UI. I'm going to commit, add workflow for front end. I'm going to post the changes, and then now let us see if the action is triggered. Let us come back here to actions, and now let us go back to the actions tab. And you can see now we have a new trigger, which is just created now. We will modify this to just trigger their respective workflow. Right now, we can see both the workflows are triggered, but we just are focused on the static web apps for now. So we'll wait for this to complete and see if we can access the front end. And we will also quickly see how we can set up a custom domain as well. Wait for this to complete. And in the meantime, while this is done, I will tell you how you can rectify or improve your workflow to just run the workflow that you need. So instead of triggering the workflow on pushing to all the branches, what we can do, if you see the reference uh, for the front end, you can see that we can define a path. So this way, for example, if I do this, copy this, and then I can go back to my front end and I can define my path. So for example, on the same label, this has to be on the same label as branches. So on the same label as branches, what I can do is I can define the paths. Sorry for the, yep. So if you define it this way, so if you define the paths, then this is only gonna work whenever there is changes to this to a specific path. So either app slash client, and we have used a wildcard to make sure that if you make any changes within any of the directories or subdirectories of the client folder, this workflow is gonna get triggered. Or if you also make some changes to the workflow file itself for the front end. So in this case, we need to use the specific name. So I'm going to have to use this one. I'm going to just replace this with this .yaml. Yep, that's how we are going to make sure that this workflow is only triggered for the front end. And likewise, you can do the same thing for the backend as well. So you need to define the backend path and just replace the name of the workflow. So in this case, it's main gsw cloudmon.yaml, and this is going to be the same. So you can have a look at the reference and check that. I'm just going to ignore that for now, but that is how you can restrict the workflow to only trigger for the specific path. That was about that one. And now let us see about if the work, yeah, this is completed. So looks like everything is fine on this end. So let me go ahead and open the um, static web apps and see if we have the application up and running. So if I go ahead and click on the URL, yeah, you can see that now the front end is loading. Hopefully, we can able to access the backend now. So if I click on Junior and save employee record, yeah, now you can see that I have the records over here. So that means that our application is able to connect. I can inspect that, and you can see I don't see any errors unlike before, right? So That means our application is working. I can edit this. So let's change this to Alex Joseph, something like that, and edit. You can see that the records is now edited. So I don't see any errors. So that means that our application is able to connect to the backend, and the backend is able to connect to the MongoDB server. So that is how we are able to access the application. So this is the process. And now let's actually see how we can use the custom domain for our front end. I hope everything is clear until now. Let's see the comments. Yep, I don't see any comments. So let us go ahead and check the domain part. So if I go on static web app, and here I can see the tab for the custom domain, right? And right now we are using the pre-default domain that is provided by Azure for us. But instead of this, let us try to see how we can actually use our own custom domain. So the first thing that you need to do is to get yourself a domain. And so get.tech it is. So I have a domain, free domain from .tech domains. You can also get that for free if you are a student and have a GitHub student developer pack. Please go ahead and get yourself a free domain from there. And I can go to account, and I do have a domain over here. If I go to my list orders, then I have a let's DevOps.tech as a domain. So I'm going to use this domain. It might be a bit small, so I'm going to zoom it out a bit. And the thing that I need to do first is to go to DNS management and manage DNS. Let me open that, and it's going to give me a pop-up, and let me zoom this a bit. So I need to add the records for our virtual machine, but for that I need to add domain on here, and I'm going to choose custom domain on other DNS because I'm not using the Azure DNS. I'm using the one from the TechGet. So the domain name is let's devops.tech, right? So that's going to be the domain name. You can see that it's let's devops.tech. So I'm going to come here, create, and then it will ask us to validate the ownership because Azure needs to verify that we are actually the owner of the domain. So we need to generate our txt record. So it will generate a value for us, and we need to insert that value within our DNS record. So that way Azure can verify the ownership of our domain. So it's going to take a while for us to to generate the domain. In the meantime, let me know if you have any questions or comments. Let me come back to the screen. Yep, I don't think we have any right now. So let us go here. Yeah, you can see that the records is now generated, and it provides us with the value of the DNS, the TXT records. And this is for the root domain itself. If you are using the subdomain, then the host value will change. So let us go ahead and actually add that. So I'm going to copy this one, copy the value. And over here under the TXT records, I'm going to add a TXT record, and the host is going to be at the red. That's for the root domain itself. But for example, you have something like gsw.letsdevops.tech, then you can change the host name over here. And this is going to be the value. And the time to live, it's the time in seconds which the domain registrar will use to cache your domain record. So I'm just going to leave it for default for now. So this record is successfully added. And Azure will take some time because it can take up to 12 hours for the DNS names to take change, but normally it should be done within 5 to 10 minutes. So yeah, it's going to take some time to validate it. And once you validate it, you can add a CNAME record. So you can see that it's validating right now. And if I click on new details, then I need to wait for this to validate. And after that, I can set up a CNAME to confirm or point a record. So for example, here you can see I can see an action of setting up a CNAME record, but I need to wait for this to validate. So even if I add it here right now, our website will not work until this is validated. So for example, I can add a record, right? So I will create a record. You can choose any of the record types, and I need to copy the IP. So this is the public IP of the my front end. So you can see that this is going to be the public IP of my front end static web app. So I'm going to copy this one. And then what I need to do is to go back to the record manager, DNS records, and I need to add the a record. and that's going to be host name. It's going to be @ because I'm going to reuse the root domain. So that is simply let's devops.tick, and then this is going to be the IP, which I just copied from here, and I will just leave the TTL as default. So I have added the record here. So I have a record pointing to my public DNS of the static web app, and I also have the TXT record. This is to verify the ownership. So I have done all the things that I need to do from the from the DNS provider side, but until and unless the Azure verifies this, we cannot do anything. So we just have to wait and see if this works. And once it you see a green tick, you should be just able to go to let's devops.tick, and you should be able to see the domain. But right now you can't see it. And also, like, since we do not have a TLS certificate, it's HTTPS. So if you want to have a SSL and TLS certificate, then you can use the HTTPS flag. And right now the website is not found because we do not have we have not configured it. So we need to wait for Azure to pick this up. So that is for the custom DNS. We just need to wait for that. We can't do anything else. Apart from that, I guess we have covered everything that we need to cover in this stream today. And in the part 3, like I mentioned, tomorrow we are going to cover, I can just quickly brief you over here. So in part 3, we are going to cover the static web apps and the the serverless approach to the deploying web apps. So tomorrow we will be deploying another application, not the same one application, but using all these serverless services, such as the Cosmos DB, the Key Vault, and we will also use Bicep to spin up the services instead of doing it from the Azure portal. So that's for tomorrow. I wanted you to show this one, but it seems like it's gonna take a while to validate. But yeah, it's as simple as going here, adding a new domain, just verify your ownership by creating a TXT record, and then add a CNAME or any of the other record types that you want, and you should be good to go. Let me check the stream back. All right, everything is fine over here, I guess. So let's wait for 1 or 2 more minutes, and then if this is validated, then that's good. If not, then you can always go to let's devops.tick. Even after the stream, I'll put it up for a while and then see if it's working. So right now it's in the state. So let me check if everything is working fine. And also, do not forget to delete the resources once you have completed your demo. Otherwise, it might consume all your credits. So if you do not need the application after your testing, then please go ahead and delete the repo. So go ahead and make sure you go to resource group. And for me, I put everything under the GSW managed resources. So I can just select everything from here, and I can delete the resource group, and it will delete all the services that we created from here. Just you need to type the resource group name. I can copy it from here, I can paste it, and then it will delete it. But I'll just keep it up for a while. And also, do not forget to delete the database that you created from here. So go ahead and delete the database cluster after you complete your application. So please go ahead and delete the database cluster as well as the application that you create. That was about it. And now for the final time, let me check if the DNS thing is done or not. Let us go ahead and check here. Custom domains. Nope, it looks like it's going to take a while. Sometimes it depends. Sometimes it's get done within 5 to 10 minutes, but sometimes it can take a bit longer. So that's just the part of waiting that. And I hope you all enjoyed the session. And let me come back to the slides. Give me a second. Yep. I hope you all give me a moment. I hope you all enjoyed the demo, and also thanks for being here. I hope you all learned something, and tomorrow it's going to be a bit more exciting because we are going to take a new approach, and we will see how we can use the infrastructure as a service, in this case Bicep, and you can use the same approach for Terraform and other things as well. So that's going to be really exciting for you all as well. And if you still have not, then there's still some time for you to check into this event. That will help you on some point if you already have not done that. So thanks for being here, everyone, and I hope you all had a great time. Bye-bye, and see you there. Bye-bye.